Well, welcome to our new chapter, chapter 11. We're going to be going through in this video and the next. We're going to talk about lesson 11.1 and graphs of sine and cosine. So we just spent last chapter talking all about our trig functions and getting familiar with the unit circle. And so now we want to go ahead and start looking through what these functions look like on a particular graph. As you can see, what I have in front of me here is our normal XY plane, but the X values are listed in such a way where it actually matches what we have on our unit circle. You can see there pi over 2, pi, 3 pi over 2. Some of those other spots could even be shorter if we wanted to go all the way to pi over 4, and so on. And so those things are going to be important for us to have in this section here. Let me go ahead and erase those. So now as we take a look at what's in front of us here, and we want to go through just a very basic sine curve and a very basic cosine curve, and see if that can wrap up this video. Both of these trig functions, actually any trig function, can be called what's called a periodic function. And the idea behind it being called periodic is that it occurs over and over and over again. So if I have a sine curve, and that's even true for us when we think of the unit circle, is that the values continually go around the circle. And so that's going to be true with what we see in each of these graphs in front of us today. So if I were to take this first example here of y is equal to sine x, there's a few things we first of all want to establish. The format for what a sine equation should always look like is y is equal to a sine bx. And so there's some specific values with a and b that we want to take a look at. First of all, a represents the amplitude. And as we talked about in our notes and in the lectures the last few days, amplitude is how high and how low a graph or a wave will get. If I were to take just an example here and maybe go back and forth like so, the highest distance that it goes away from equilibrium and the lowest distance that it goes from equilibrium is called our amplitude. This is true for simple harmonic motion. It's true when we just discuss sound waves or light waves. Whenever we describe in science, we describe a wave, we're going to talk about amplitude and the distance that it is away from equilibrium. And the equilibrium is represented by the x-axis that we have in front of us. So for the a value here in our sine equation, that is going to be represented by the amplitude, and so that value is going to be important. You can see even here on this example, since there's no number right in there, we're going to assume that it's an understood 1. So the amplitude for this particular graph is going to be 1. So we're going to try to keep this easy and simple to start us out. So let me back up here just a second. So let's say we've got this established, that A, and in your textbook they'll talk about it being an absolute value. A is the amplitude, and so here for this equation it's going to be 1. And then another term that comes up with waves, since we just called it a periodic motion or periodic wave or curve, then we're also going to say something like this. We have the period of the graph. And again, it has this idea that it's continually happening over and over and over again over a certain period or a certain time. So period is represented by that letter B, okay? But there is an equation that goes with it. So we're actually going to take 2 pi divided by the absolute value of b. 2 pi divided by the absolute value of b. Now in this case, since we just have a very generic equation, sine x, our amplitude is 1, our B value is 1. So we're going to have an amplitude of 1 and a period of 2b, or sorry, 2 pi, not 2b, 2 pi. So we'll say that. We'll say our period is 2 pi. Okay, so we've got our amplitude, we've got our period. Now the next thing we're going to do is really important, is we want to refer to our unit circle and see if we can fill this chart out. If I were to go to the 0 value on the unit circle, then that means I have an x value of 1 and a y value of 0, right? So that means my y value, since sine is the y value, then I'm going to have 0 right here. At pi over 2, I'm going to have a y value of 1. So I'm just going to those main quadrants on the unit circle, and it'd probably be really helpful for you as we watch this video to maybe have the unit circle sitting in front of you so that you can see. At the pi value, we know it's going to go back to 0. At 3 pi over 2, we know it's going to be at -1. And then at 2 pi, we're going to be back at the beginning because it's going to match exactly what I have here at the 0. Now, since this is periodic, and also since this is repeating, we have a period of 2 pi, then I know that all my values are going to match up from one side to the other. So if I were to go to negative pi over 2, so I go down the circle, that means I'm going to go to -1. I'm going to be at 0 again. I'm going to be at +1. And then I'm going to be at 0. So I'm really just alternating 0, 1, 0, -1, and then back through it all again from, in this case, we're doing -2 pi to +2 pi. But knowing that our period is just 2 pi, we really would only have to do half of this graph. But I'm going to go ahead and show you at least 2 periods worth, just so that you can see what these values are representing. Now, the last thing is just to be able to plot these points. On my graph for my y values, I'm going to go ahead and make each 2 dashes there. I'm going to make that worth 1, just so that I can see a little bit better what I'm graphing in front of me. So what I'm going to do now here is I'm going to start plotting these points. So I know that I've got 0. At pi, I also have 0. At 2 pi, I have 0. And I back it up. Once you start, the cool thing about sine and cosine graphs is that once you start to see the patterns, it's pretty easy to go through and plot the points that you're looking for. -1, +1, and that should be it. So ultimately what should happen is I start to combine these points in a nice smooth curve. I show a graph that is repeating from, I could even say this, from 0 to 2 pi. That picture, that graph is what's going to get picked up and laid down right next to it, picked up, laid down right next to that, and just continues on and on and on, going from 0, 1, 0, -1, back to 0, and then continue that on as it goes through. So the amplitude we can see is just a distance of 1 or -1. The period, 2 pi, as I'm going to see an entire picture, I'm going to see a crest. That you might have learned some of these terms in physical science. I've got a trough. So those are my highest points, my lowest points. My equilibrium is, again, the x-axis. The amplitude is how high and how low I'm going to end up going for this particular graph. Now let's look at a cosine graph, see what that's going to have for us, because there are 2 different things that occur between cosine and sine graphs. If you remember back to the sine graph, we went through the point 0, 0, so that's really important to remember. We went through the point 0, 0 for our origin. Cosine is going to be a little bit different, but it's still going to have some things that repeat and come up again and again for us. So as we look at our standard, y is equal to a cosine bx. A is still going to be our amplitude, so that doesn't change. Amplitude. The period is going to be 2 pi over the absolute value of b. In this case, since our b value is an understood 1, then we're just going to have a period of 2 pi. So these two are your basic ones to start out. We're learning sine and cosine curves. We're not going to get super creative with any kind of transformation just yet. We'll see that in the next video. So the amplitude we can see is 1, so we're not going to go any higher than 1. I'm going to make sure my graph has these values written in here, -1, -2. And let's go ahead, using our unit circle, let's think through each of these values at the quadrants. At 0, we know that cosine is the x value, and so it's actually equal to 1, which means at 2 pi and -2 pi, that's also going to be true. I don't know, my play button for this recording is right there in the corner with 2 pi, so I have to write that off to the side. So now we're looking at, let's see here, for pi over 2, I know that my value is 0 and 1, so that means this is going to be 0. At pi, I'm at -1, and at 3 pi over 2, I'm at 0. So I've got 0 here, which means I more than likely have 0 here. Hopefully I'm not confusing you too much with the fact that we can just go at certain points around the circle and we know where it's going to be repeating. At -pi, I know I have -1 because that ends up at the same place here and here for pi and -pi. So hopefully that you can see we're still going through some of those same values, 1, 0, -1, 0, but it is slightly different than the sign because at the origin, we're actually going to go through the y-axis right up here at 1. Then I'm going to proceed through all my values so that I've got 1, 0, -1, 0, 1, and then we'll go back here again, 0, -1, 0, and +1. So now we can finish continuous curve here, knowing that it does continue on to the left, it does continue on to the right. The important thing to know about the cosine graph is that it does cross through the y-axis right up there at the 1. The y-intercept is at 1, whereas sine of x, it was actually passing through the y-axis at 0. So those two differences are really important to note for sine and cosine. So it shows us again, we've got a period of 2p, or 2 pi. So here and here, even though that doesn't look like it's a full crest and trough, it actually is, because it will continually repeat. I've got half of a wavelength here, and then I've got the other half of the wavelength here. So it does match up with what I'm looking for as far as a full period being 2 pi and an amplitude of 1. So still looking at the distance from here to here. Distance from here to here is a value of 1. So those are your basic sine and cosine graphs. In the next video, we'll take a look at anything that would give it a translation or a reflection.